Hello friends, welcome to Shiksharthi. In this video, we shall be discussing time and work. So let's start. So as always, we'll be dividing this topic time and work in few videos. So in this video, we are basically going to talk about the chain rule, the man-day concept, and how is it used. I mean, talking about two or more people working together and so on. And at the same time, we'll be talking about few terms and we'll be using the concepts of ratio, proportion and variation in time and work, right? So for further discussions, whenever we are talking about capital T, we are talking about time, the time taken to do a piece of work, and W is for a piece of work, and E is the efficiency of doing work. So can I say the rate of doing work is efficiency? If the answer is yes, then we can establish a formula, and the formula is efficiency is rate of doing work. So which can also be understood as one work done in 1 unit of time. So 1 unit of work done in 1 unit of time is known as the efficiency of doing work or the rate of doing work, right? Okay, taking this discussion forward, so we have divided this session, this video into 4 parts. Now when I say 4 parts, we are going to talk about basics and the concepts in these 4 parts. Okay, so the first concept that we are going to discuss here is the concept which uses ratio, proportion and variation. So for example, if I say keeping the time taken to do a piece of work as constant. So for further discussions, whenever we are putting a circle around something, that means we are talking about that remaining constant. So when the time taken to do a piece of work is kept constant, can we say the more efficient we are, we'll be doing more work? So it is just like saying, when I know that efficiency is work done upon time, if time is kept constant, efficiency becomes directly proportional to work done. So if my efficiency, if I say my efficiency of doing a piece of work increases, so if the efficiency increases, it translates into the increase in the units of work being done. And if my efficiency decreases, the unit of doing work also decreases. At the same time, if my efficiency remains the same as it was, the work to be done remains the same as it was supposed to be done earlier. So when we say that efficiency is directly proportional to the work being done, keeping the time constant, any change, delta here signifies a change. For further discussions, whenever we are using a delta here, delta means change. So any change in efficiency will be directly proportional to the change in the work being done. Okay, if I say that my efficiency of doing work is constant, so if you give me more work, I'll be taking more time. If you give me less work, I'll be taking less time. If you give me the desired piece of work, I'll be taking the desired unit of time, is what we are discussing in the second part. And the third part here is, if somebody tells me that the work to be done is kept constant. For example, if somebody has to finish 1 unit of work, can I say the more efficient we are, we'll be taking lesser time to do the same piece of work? Right? So if I'm more efficient means delta in E. I'll be taking lesser time to do the same piece of work, which means delta T. And if I'm lesser efficient, which again is delta E, at the same time I'll be taking more time to do the same unit of work, which is again delta T. So what is the role of delta? So no doubt that delta signifies what? Change. Now this change, as we have discussed earlier also in my video on percentages and fractions and ratios, we have talked about this delta many a time. So this change may be what? Either negative, positive. So the moment I use a word like more, it signifies plus. The moment I use a word like less, it signifies minus. And 0 is what? No more, no less, which is no change. Right? Okay. Taking this discussion forward. Now, if I were to take this with the help of an example. So if somebody tells me that there's a piece of work that is supposed to be done, and because of some reasons the efficiency of the people have gone down. I mean, the efficiency of the people has gone down. The efficiency has gone down and it has reduced to a half. So when the efficiency reduces to a half, which is just like saying the efficiency originally was how much? E. Now it reduces to how much? E by 2. How much time would be taken? So if originally the time taken was T, now the time which would be taken would be 2T. Why? Because efficiency is inversely proportional to the time. I hope you understood this. Okay. Another way to interpret efficiency is what? The quantity of people being involved also translates into efficiency. For example, I can say that, I can always increase the efficiency of the group by asking them to put in their 100%. Let us say the efficiency of the people had gone down to a 50%. I can always ask them to increase their efficiency. One is, I know if they cannot increase their efficiency, what is the second way of increasing the efficiency of the group? By including more number of people in the group so that the cumulative efficiency increases. So there are two ways of changing the efficiency. One way is increasing the number of people involved, or decreasing the number of people involved, or no change in the number of people involved. This is how you can alter the efficiency of the group per se. Okay. Now taking this discussion forward, now I'm going to discuss it with the help of an example, and then we'll be establishing the chain rule. So if somebody tells me that 2 men are supposed to do 1 unit of work in 5 days, then 1 man to do the same unit of work, which is 1 unit of work, will take how many days? Now before I begin with this, is there anything that you can associate from here? So a few minutes back we were talking about there are 2 ways of changing the efficiency. One way is I ask the people originally involved, or I can always increase or decrease the number of people involved. But if I increase or decrease the number of people involved, naturally the time also changes accordingly. So when I know that the work done is kept constant, which is this case, so if I reduce the number of people keeping their efficiency constant, will the time here increase or decrease? It has to increase. So how would it increase? It would increase by this multiplicative factor. I hope you understood this. So we are using the same concept here in a question. And this we are taking it another concept. Relatively now we are taking this as another concept. So if 2 men do 1 piece of work in 5 days, 1 man would do the same piece of work in greater number of days, but these greater number of days would be 2 into 5, which is 10 days. Now this question can be just made the other way around. So this was one side of it. Now I want to go the other side of it. The other side of it is the statement remaining the same. Now what I want to prove here is, here we were asking how many days would 1 man take. Here we are talking about 1 day requires how many men. So the concept still remains the same. Now when you are reducing the number of days, naturally if you are, so you need to increase the number of people to increase the total efficiency. Let us say keeping the work done constant. So when we are saying efficiency, actually this translates into keeping the work done constant. So this is basically what we are talking about, keeping the work done constant. Why are we saying keeping the work done constant? Because we are doing 1 unit of work. Okay, so if 5 days are taken by 2 men to do 1 unit of work, in 1 day to do the same unit of work, you'll be requiring more number of people because efficiency is inversely proportional to time, or quantity of men is inversely proportional to time. So here you can understand it as Q for quantity. So now when we are saying keeping this efficiency constant, we were talking about the men, those who were originally involved, keeping their efficiency as constant. Right? which was just like saying keeping the work done constant, because we are keeping this unit of work to be done per day or in 5 days to be constant. So one day would require how many men? It would require greater number of men. Now from here we are trying to establish the chain rule. What is the chain rule? So I am converting this into a formula. If m men do w units of work done in t days, one man would take how many days? M into t days to do w units of work, right? Similarly, 1 unit of work. Now if w units of work takes t days, if you give me, so what are we saying basically? We are talking about this, w takes how many t days. So w units of work take m into t days. So naturally 1 unit would take lesser number of days, because work done and time are directly proportional to each other. So from here we are able to establish the chain rule. And using the same concept now, so what are we saying? We are saying m1 into t1 upon w1 is equal to m2 into t2 upon w2. This is the chain rule. What is w1 and w2? Now this 1 signifies one set of people, and this 2 signifies, in the subscript, it signifies another set of people. So m signifies the number of men involved. Men is just figurative here. So we are just trying to explain the man-day concept. This was the entire man-day concept that we are talking about, and with the help of man-day concept we are establishing the chain rule. So 1 signifies one set of people, the number of people are m, the time taken by those people to do w units of work is t1. Similarly, this is another set of people. So this is what is known as a chain rule, which you can use. Okay, now talking about another kind of questions or concepts which you would get in a chapter like time and work. So, and what are the kind of questions that you can get? Either we will use a terminology like this, or we will use a terminology like this and this. So you will see generally the questions will use this terminology only. Now what is the terminology that we are talking about? The question may say, or the concept may say, 2 men or 3 women do a piece of work. Let's say a piece of work, a means 1 unit, in 5 days. So one thing that you need to understand from here is 1 man would take how many days? As we had discussed earlier, it would take 2 into 5, which is 10 days. 1 woman would take how many days? 15 days. Who is more efficient? The person who takes lesser number of days? Okay, so from here, the person who takes lesser number of days is more efficient, and less efficient is the person who takes the person who takes lesser number of days is more efficient, and the person who takes more number of days is lesser efficient, right? And this is the sign that we are using for efficiency. So can we establish a thing from here? We can establish, can we say that 2 men will be equal to 3 women in terms of efficiency? Yes, because men are more efficient than women. So this relationship we have established with respect to efficiency. Right? Okay. Similarly, in 1 day, how many men would be required? So in 1 day, how many men would be required? 10 men. Or how many women will be required? 15 women in 1 day. Now why are we taking lesser number of men and more number of women? Because it is very obvious that the men are more efficient than the women in this question. Okay, we are not carrying any gender bias. In this question, it is happening like this. Okay, similarly, you will get another variety of a question here which says 2 men and 3 women. So here, and is always together, and or is always mutually exclusive. I mean, either 2 men would be involved in doing this piece of work, or 3 women would be involved in doing this piece of work. But the moment you use the terminology like 2 men and 3 women, that means they are working together. And here in this question or concept, they were working in isolation. They were not working together. Okay, they can always be made to work together after this. Okay, so from here, can I say that 1 man and 3 by 2 women. I mean, naturally you cannot have non-integer women, but just for the sake of understanding, if I make it as 1 man, so here this becomes what? 3 by 2 women to do the same unit of work, which is 1 work, will take how many days? It will take more number of days, which is 10 days. And similarly, if you divide it by 3, why are we dividing it by 3? This thing, so that I have 1 woman, and if I'm converting it into 1 woman, in that case, 1 woman, so in that case, I'll be requiring how many man or men? I'll be requiring only 2/3 of a man, which I know that, or we know that we cannot convert men into non-integers, but just for the sake of understanding, will require how many days? 15 days. Now, if I take it the other way around now, so we are doing nothing but we are discussing what we have already discussed here. So can I say in 1 day, I'll be requiring how many men? I'll be requiring 10 men and how many women? 15 women to do a piece of work. So whenever you are doing such kind of questions, it is advisable that you either convert it into 1 day concept or convert it into a 1 quantity concept. 1 quantity concept here means either you convert it into 1 man or 1 woman, or you convert it as 1 man plus 1 woman. Right? I hope this has been fairly understood. It is advised that you should go through this once again so that you are able to form an opinion. As discussed earlier, we will be discussing few more concepts on time and work in the subsequent videos. If you feel that today's video was informative, please do not forget to like, share and subscribe to our channel. If you have already done so, just click on the bell icon and select all so that you start receiving regular updates from us. Thank you so much. Until next we meet, goodbye.